Good afternoon everybody. I am Shailza Kamal, working as an assistant professor in Department of Computer Science and Engineering in Baba Hira Singh Bhattal Institute of Engineering Technology, Laharagaga. Today's my presentation topic is based on database modeling concepts and transaction processing. We will start this topic with the help of introduction, small little bit introduction about the relational database management system. First of all, we will discuss what is an relational database management system. So, relational database, exact definition is has any database for which the logical organization is based on relational data model is known as a relational database system. There are some common concepts in relational database management systems are the first one, data is layout as set of relations that is known as a records. Second point, a relation describe a table. Third point, the columns are known as attributes, and the fourth point, rows that is basically are known as a tuples describe an entity. And the last one is a table has set of attributes called as a key. The key specify an unique entity. So these are the basic 4 or 5 concepts that included in the database management system. The next is the relational database model basics. That is, a data is viewed as existing in two-dimensional tables that is known as a relation. Here I show you the tables, the first table, second table, third table and the fourth table. Second point, a table has set of attributes. This is called as a key. The key specify an unique entity. And the third, in addition to primary key, a relation use a foreign key that refers to a set of attributes in some other relation. So these are the 4 basic tables that show how one table relate to another table or how one attribute relate to another attribute. This is a relational database model concept. Now next important is relational schema. A relational schema, that is R, is represented with the help of R, having some attributes. This is A1, A2 and AN is made up of a relation named R, and a set of attributes, that is A1 and A2 are the attributes of relation R. Each attribute AI is the name of a role played by some domain D in the relational schema. So these are the some concepts of the relations and schema. We having a some table, this is known as a relation name having a flight schedule, having flight integer, airline, weekday and price. These are the attributes of that flight schedule, and the integer, care 20, care and decade are known as the values that assign to that particular attributes. These are known as the attribute names. Second table, flight schedule, having this, the flight is known as a primary key, having some another table, customer having another primary key, and the related to next reservation table with some another primary key. There are some important relational keys concepts. There are mainly 4 types of keys. These are primary key, candidate key, super key and the foreign key. The first one, primary key, a candidate key related to identify tuple uniquely within a relation. The candidate keys that are not selected to be the primary key are called alternate keys. Candidate key, the super key is such that no proper subset is a super key within the relation. A candidate key that is represented with K for relation has 2 properties. First one is uniqueness and second is irreducibility. Third important key is known as a super key, an attribute or set of attributes that are uniquely identified tuple within a relation is known as a super key. Next is foreign key, an attribute or set of attributes within one relation that matches the candidate key of some other relation. The appearance of a foreign key usually represent a relationship between the tuples of the 2 relations. So these are the 4 important relational keys in our database system. This is a table. The first table is a customer and the second as a depositor and the third is a account. You can see here the customer ID, customer name and the customer street, customer city of the first table are the basic attributes having represent with the columns, and these are the some important entries under this table. And the second table is depositor and the third is account. Same is here, customer ID and account number are the attributes, important attributes of the depositor table, and the account number and balance are the attributes of this account table. You can see in the first table the customer ID is the primary key of that table, and the next table customer ID is the primary key of depositor table, and third account number is the primary key of that particular table. If we relate these tables with each other, then the account number and the customer ID is known as a foreign key of that particular table. You can see. Now I move to next slide. Next very important concept of data modeling is relational integrity. First one, entity integrity. It ensures that each row in a table is uniquely identified. Placing a primary key constraint on a specific column most often enforces entity integrity. Next is referential integrity. It states that foreign key values must match a candidate key value in its home relation, or the values must be null. It is enforced with a primary and foreign key combination. The third one is a domain integrity. It refers to the set of permission tables values for an attribute. It can be enforced within a default constraint, the foreign key check constraint, and the data types. Next is known as a user defined integrity. It refers to specific business rules not covered by the other integrity categories. It is implemented through the triggers and stored procedures. So, these are the four types of integrity: entity integrity, referential integrity, domain integrity, and user defined integrity. This is a database design model. We can say in the real world situation, we having some important functions. For example, we having a data model including conceptual model. Next is a logical model. In the first data model, the conceptual model is basically known as a independent of DBMS, and next also DBMS dependent. Then it relates to the data dictionary. Next, user application program having logical data independently. This data dictionary including the three main concepts: first one external schema, then conceptual schema, then internal schema. The conceptual schema is basically known as a logical definition, and the internal schema is known as a physical definition. And the other side, this is known as a basic database, which includes the views and the table, and the table relate to next internal schema, conceptual schema, and external schema, and this is followed by database independent concept. This is known as a physical data independence. You can see in this slide the in real world how these model interconnected with each other. Next very important is known as a database management architecture system. This is very important concept, very important slide. You can say in our database system, in whole system, the database including the important users. This is first one is known as a naive users, then application programs, then sophisticated users, then database administrator. The first naive users that use application interface. Second, application programmer, these used to write the application programs. And the next is sophisticated user, which used to analyze, it use query tools. And the next is database administrator, it use administration tools. And now next they are again interconnected with the query processor. Next the table is known as a box is known as a query processor. What is the task of query processor in this architecture? It accepts the whole applications from the above users and link and forward the next data to the storage manager. Then the storage manager store the important data and forward to the disk storage. This is permanent storage. Now the query processor includes application programs, object code, then application programmer used to compile and link this program, then query tools used to DML database management concepts, query tools DMLs, then data definition language interpreters, then DML compiler and organizer, then this combine goes to the query evaluation engine. This query evaluation engine forward the data to the buffer manager and the file manager, and next is used to authorized and integrity manager and then forward to transaction manager. These are 4 types of manager are under the storage manager, and then they forward the data to the disk storage device, which includes the whole data, indices, data dictionary and statistical data. This is the important architecture of the data modeling or relational database management system. Now I move to next slide. Next, very important is important components of relational database management system. This concept includes a database users. We already discussed in the previous slide what kind of users, then the applications, then the application object codes. The database users are database users can be categorized into application and user, programmer, data analyst and database administrator. Then the application, it is a collection of programs that help to validate and maintain the business information in the database. Next, application object code, it is a compiled program from high level language statements into machine level executable code that helps to execute application instructions through the operating system. Now, relational algebra and calculus, the basic set of operations that enable a user to specify basic retrieval request for a relational model is known as relational algebra. The sequence of relational algebra operations form a relational algebra expression whose result is the relation that represent the result of database query. Now, relational calculus, what is relational calculus? It provides a high level of declarative notations for specifying relational queries. In a calculus expression, there is no order of operations to specify how to retrieve the query result, specifying only what information the result is to carry. Next is relational algebraic operations. This operation include the unary and the binary number and the set operations. The unary and binary concepts include the select, project, join and the division operations, and the set operations include union, intersection and minus operation. This is the operation which shows the selection operation. You can see in this slide. Selection, it is used to select a subset of tuples from a relation that satisfy a relation, that is known as a selection condition. Example, select students with the GPA higher than this from S1. So, the S1 select the student which having higher GPA in this slide, and this sigma notation shows the selection operation. You can see this used to select these two rows from particular this operation. Then now next is projection. The project operation select the certain columns or attributes from the table and discard the remaining portion. For example, project the name and the GPA of all students in S1. Then I can show how this projection operation works in this slide. used to project two particular columns. This is the example of projection operation. Now next is a set operation. There are basically four important types of set operation in the system. The first is union, intersection, set difference, Cartesian product. The union, the result of this operation is a relation that include all tuples that are either in R or S or both in R and S. The duplicate tuples are eliminated. Intersection, the result of this operation is a relation that includes all the tuples that are both in R and S. And the set difference, the result of this operation is a relation that includes all the tuples that are in R but not in S. And the next is Cartesian product, the result of R that includes attributes A1, A2 up to n and S that include B1, B2, Bn is a set of relation Q with the degree n plus m attributes. The Q represent the combinations or the projections of both A and the B such that Q has one tuple for each combination of that tuples. Now you can see the example. Now the division operation. The division operation denoted by this symbol is useful for special kind of query that sometimes occur in a database application. An example is find sailor who have reserved all the boats. Let A have two fields x and y and B have only a field y, then A divided by B. This formula denote how the division operation works. The next, A divided by B contain all x tuples sailors such that for every y tuple or example vote in B there is an x into y tuple in A. If the set of y values or boats associated with an x value sailor in A contain all y values in B, the x value is A divided by B. Now this example of A division by B, you can say in this slide the A, B, B2 and B3. Next is the join operation. The join operation denoted by the symbol this is used to combine related tuples from two relations into a single tuple. This symbol is known as a join symbol. The result of R and the join symbol join condition is S is a relation Q with the degree n plus m attributes, the Q having some attributes such that Q has one tuple for each combination of tuples satisfying the join conditions. Equijoin, a join that involves join condition with equality comparison is known as a equijoin. And the natural join, the standard definition of natural join requires that the two join attributes have the same name in both relations. Example, you can say the example is the join operation. So before going to start the transaction, I revise the topics of important relational operations. These are we discussed the selection, this example of selection, and this is an example of projection. And therefore, we have discussed the 4 types of set operations: union, intersection, set difference, Cartesian product, and these are the examples. We have discussed the division operation and importance of equijoin and natural join. Now we will move to a concept. This is known as a transaction processing and database modeling system. The transaction is basically known as an existing program that forms a logical unit of database processing. The basic database access operations that a transaction can include are the read item and the write item. In transaction processing, the read item reads a database item named X into a program, and the write item writes a value of program variable X into the database item named as X. There is a sample of transaction. We are having a 2 types of transaction, that is simply T, it having the 2 operations X and Y. The T0 and Tk, it denotes the time from T1 to up to Tk. The T1 transaction 1 first of all read the item, and again the Y is used to read the item. If the operation is X is equal to X minus 40 and the Y operate as a Y plus 40, then the item write, it gives the output to the user that write item X and write item Y. This is a simple example of transaction processing, how a transaction works like here. Again, there are important concept of the transaction processing are, these are known as acid properties. So, we will discuss what are the acid properties on a transaction processing. It is very important concept. Basically, a transaction processing based on these 4 types of properties. The A is stand for atomicity, and the C stand for consistency, and I stands for isolation, and the D stands for durability. Now, first is A, the atomicity. Transaction is either performed in all its entirety or not performed at all. This is known as atomicity. And the C, consistency. Transaction must take the database from one consistent state to the another. And the I is known as isolation. Transaction should appear as though it is being executed in isolation from other transactions. And the D, durability, the changes applied to the database by a committed transaction must persist even if the system fail. This is known as a 4 important types of properties under the transaction processing. This is known as a acid properties. Now, these are the states that are based on the previous properties. The transaction states works on these 5 type of stages. The first one is active state, then partially committed, then committed, and then failed and terminated. Basically, these states represent how the transaction processing states basically works. This is a transaction sample T1. It basically based on these types of states, which transaction occur in which type of state. The first is known as a begin transaction, then read and write operation we already discussed, then end transaction, then commit, rollback or abort transaction. This is a example sample transaction T1. It means the transaction is begin from here T1 start the transaction, and the second stage is known as a read and write item, then transaction is activated state, and Tk where the transaction ends, this is known as a transaction is terminated here. This is the example of these particular stages. So, this is the begin transaction is in active state, then the operation is used start, read and write. If the transaction fail, then its abort goes to the failed state. If the transaction end, then or not partially end, then it is known as a partially committed, and if the transaction commit, then it is known as a committed state. If the transaction again failed, then it goes to abort the transaction. If the transaction fully completed, then this is known as a terminated state. These are the basic 5 type of stages or states in a simple transaction processing. You can see here. Next is known as a concurrency control stage in our transaction processing. Basically, concurrency control is known as a how the transaction can be easily controlled with the help of various processing control systems. So, first we will discuss what is an concurrency control system. The multiple users access the database and use the computer system simultaneously. For example, airline reservation system. This concurrency control system basically address how the more than 2, 3 or more than various transaction processor works simultaneously in a system. So, this is known as a concurrency control, how these various types of systems or transactions can be controlled easily. So, an airline reservation example is used by hundreds of travel agents and reservation clerks concurrently. The concurrent process guarantees the following. The first one is known as a increased processor and disk utilization. Second, reduced waiting time. The first one, increased processor and disk utilization, it leading to better transaction throughput. One transaction can be using the CPU while another is reading from or writing to the disk. Then reduced waiting time for transaction, that is short transaction need not wait behind long ones. This is an example of concurrent transaction. We having two types of processing. First one is the interleaved processing, second is parallel processing. You can see in this slide the two transaction T1 and T2 are moving in a CPU. In a single CPU, it is known as a interleaved processing, and is multiple CPU, it is known as a multiple processing. There are two processors A and B, you can see, and the timelines T1, T2 shows the timelines. Now, inconsistency in concurrent execution. So, what is inconcurrency? The concurrent processor may end up violating isolation property of the transaction if not carefully scheduled. This is known as the inconsistency in concurrent system. For example, we having a reserved seat for a flight. If the concurrent access to data in a database system, two users may try to book the same seat simultaneously. This is an easy example of inconsistency in concurrent execution. These are the examples you can see. The two or more than two passengers want to occupy the same seat. This is a very best or easy example, and in the same time on the same seat. Then how the problem can be solved? This is an example. The problem can occur when concurrent transactions execute in an uncontrolled manner. For example, the original value of A equals to 100. After executing transaction T1 and T2, R is supposed to be 100 plus 10 minus 8 is equal to 102. This is an example you can see in the table. Now next is schedule. What is a schedule? A schedule, S stands for schedule of an end transaction and is multiple transactions T1 and T2 up to Tn is an ordering of the operations of the transactions subject to the constraint that for each transaction T1 that participants in us